All right, thanks for coming to the Nerves Meetup, everybody. This is sponsored by Redwire Labs. We help companies do product development with nerves and build connected products. Some of the things we have out there to be able to play with are custom nerve systems for a few different types of computers here. So microchip SAM A5D27 is a great little low-cost option that you can either get as a microcontroller or as a SOM. So great option for industrial controllers and gateways and those types of applications. The Texas Instruments AM62, which you can get from a 1 to a 4 core processor. So got some pretty decent horsepower there. This can start being used for things like machine vision and other system control type applications. And then the CompuLab Gateway, which is a little more off-the-shelf type solution that you can white label. It comes looking like that box right there with industrial I/O and dual Ethernet ports and cellular options and so on. So cool nerve systems there that we provide. Those are available on GitHub, and we also help companies integrate their firmware into those systems. Also, just as an update, we were able to add a new feature to Spec. Spec is an input validation library. We were able to add a strict validation feature to this. So instead of coercing your inputs first into your data types, this is now able to check those data types and throw a validation error if it's the wrong type coming in. Two different ways you can do this. Globally by adding a strict true option, and then you can opt out on each attribute with strict false, or you can opt in per attribute by adding strict true there and not using the global setting. Going through some of the announcements here, I think we don't actually have any announcements this time. Things are kind of slowing down in the holiday season here, so we'll get straight to the presentation with Eric presenting on nerves on the Spotify car thing. So I will let Eric take it away here.
Like Alex said, name's Eric Rauer. I'm going to talk about porting nerves to the Spotify car thing. Going to go into the weeds a bit, but I think hopefully this presentation is useful as some reference material to come back and look at in the future. So sort of the intro, I'm going to go down into the history of the Spotify car thing, the hacking community that formed around it, start getting a little deeper into up and running with Buildroot, my steps for porting nerves, and then sort of where the project is and what the next steps are. So the history. So what is the Spotify car thing? I say, or was, because it's just basically a simple device that allows the user to control their Spotify on their phone through voice recognition, some preset buttons, and it was really a sort of a dumb device in that all the communication was to your phone. So think of, it's a odd device in that, phones became more powerful, user interfaces on phones became more powerful, things like Car Thing and Android Auto became more pervasive. So I think it was an interesting project at the wrong time. So it first launched at, April 2021, $80 price point, which, definitely not the greatest price point. By a year later in July, they started the discount to $50. Then quickly after that, in August, to $30. That sort of spurned some researchers and security community to say, let me take a look at that. And quickly were able to find an exploit and get a root shell on the device. Then, device sat out there for a year or so. And then May of this year, they announced they were going to discontinue, an end of life the product and brick it as of December. And after some pushback, they started to offer refunds. So, I was lucky in this time to get a couple, my hands on a couple and basically get a free device that I can hack on. So the general specs, it's an Amlogic Cortex A53, has a video driver, small screen, decent resolution, Bluetooth, 4 gigs of RAM. Not great or 4 gigs of storage, not great, with half a gig of RAM, a single USB port for charging, a microphone, and support for the Hey Spotify wake word. So the hacks. So the first was really an article and a tool for Superbird bulk command. Basically, the researchers found that if you booted the device and held the first and fourth button, that there was a built-in, you know, design, I think they called it, insecure by design, where, it you could boot directly into U-boot shell, so you could update the partitions, back up the partitions, disable Android verified boot, and so this made the device interesting. The original tool was mainly for Linux, used some I think, proprietary binaries. So the community created a Python script that allowed you to do a little bit more, back up individual partitions. When you first plugged the device in, it looked for if you're running on the Spotify charger, started to allow you to update U-boot environment for a lot of other things. And then, to iterate, you could set the device to go into USB burn mode every time you boot it. The other people started to build pre-built images. The Debian kiosk project, has a modern version of Debian with a full screen Chromium kiosk, but the old 4.9 kernel. And, it's a little hard to use because the networking uses gadget mode, and to get internet connectivity, you have to do some IP tables shenanigans to be able to use the device. So think of this like someone has a home assistant here. They have this device connected to a Raspberry Pi or another SBC and use it for that. So this is where I began to get interested. There's Alex Chaos, not sure if I'm saying the name correctly, but he was able to modernize this device in a number of ways. Created a Linux 6.6 kernel, including a more modern device tree, built a NetRD image, which is useful for being able to boot the device without mounting the existing partitions, so you can repartition and change some of the things on the device. Built-in partitioning tool, did another kiosk project and had, Sway for Wayland working and Bluetooth support. Definitely very into the weeds with U-boot environment customization, and still using gadget mode and host IP tables, but this project really is just a guide. It's not a fully working build root environment, but he did have some references to using Ethernet and Wi-Fi connected to the device. So just a general look at what the partition layout was. So AM Logic has their own proprietary partition table, but generally, if you look at this, you can see, it's got the bootloader, U-boot environments, has some secure boot partitions, and has A and B partition support, but has a large data partition at the end of 1.5 gigs. So, as I looked at the build root, looked at all the specs, these are some of the criteria I used to determine if it was worthy of running nerves. So my concern with the initial 4.9 kernel is, you certainly don't want to get stuck on a kernel that's not updated. The 6.6 kernel was good. There weren't any proprietary or binary drivers in there. Memory wasn't great, but the fact that the other thing is the quad core Cortex A53 is actually the same processor used in the Raspberry Pi Zero 2W, which is always a mouthful to say. But, the available distributions, it's certainly possible to go from a Debian distribution to nerves, but Buildroot was definitely an easier target to go from. Yocto is another target that is, I know Redwire Labs has some expertise in porting nerves from that. So this is where we start to get into the weeds. This is, you know, some of the stuff I say for people who have not been through the nerves customizations may seem a little scary. If this is an area that, after going through this distribution or this presentation, you're concerned, I know that Redwire Labs has some expertise here, and then also Underyard, Lars has some expertise on the Raspberry Pi CM4 systems, and certainly I'm looking for opportunities as well. So one of the things really to plan this out, I had to dig into the boot flow. So I would have rather started with a dev kit and understood all the ins and outs there, but this is a device that, it's factory sealed. So understanding the boot flow and what needed to be done was the first step. So as you look at these different stages, I'm ignoring the security bits, but by default, the intent of why this device was shipped is, you should do the first ROM code execution, do signature verification along the way as each of these steps happen. So the ROM code happens first, then a proprietary bootloader stage, then U-boot, which U-boot is an open source boot manager with a lot of capabilities. But this is where, the hardware, most of the hardware initialization, the kernel, the device tree, and the boot arguments are set up. And I should say, one of the things I did decide to do is if I was starting from scratch, I would probably, include U-boot as part of my system. But what I decided to do was leave Spotify's version of U-boot in place and do all the customizations after that stage. So what is the device tree? A device tree basically is a way to take a standard kernel and change some hardware capabilities, in more of a platform independent manner. So think of it as you have a dev kit populated with I2C, SPI buses, other devices. When you go to ship your product, you may depopulate some things, change mappings, other things. So this allows you to customize the system without going into deep kernel customizations. This is just more of a capabilities. I'm not going to go into each of these, but basically, if you have access to a running Linux system, there are ways to get the loaded device tree, the kernel config, modules that are loaded at boot time, and other information. So my initial deep dive was working on the Buildroot config, focusing mainly on the initRD. So I know that I have a device that I'm going to need to repartition. I needed to get this thing up and running in a way that I could bootstrap nerves on top of it. So key things I did was fill out the Buildroot config, pulling in the custom kernel. There was some hard-coded paths and other things I changed. Make it work with gadget-based networking without IP tables. That way I can SSH into the device, do what I need to do, and not worry about setting up my host machine to deal with that. FWUp, which we'll talk about later for partition and updating the NERS firmware. I set a hard-coded, user name and password on SSH, and then did GitHub action-based CI builds. That way, anyone can take the work I've done and load it onto their device. So the output of my system is really a kernel image, a root init RAM file system. So this is just a minimal file system meant to run in memory, and the device tree overlay so that everything's up and running on the device. So this you're able to boot the device SSH into it without mounting the file system on the eMMC. So this is the general boot sequence. U-boot shell loads the kernel image, um, loads the device tree, mounts in an RD, sets the execution, initial, so basically we go all the way through the init sequence to running SSH. So now that I have a skeleton of a build root system, these are the steps that I sort of went through to get nerves working. So the goal of it was to boot nerves. The definitely a very high in the priority was avoid bricking the car thing. As we talk about the steps to bootstrap nerves, there are a couple steps that, if done incorrectly, I assume would totally brick the device. And then the third, my original intent was to allow for restoration to factory defaults, but given the timetable, I'm not that concerned on it. So, how I built the system. General steps are identified and cloned an existing nerve system, set up the build tooling, started just iterating through the differences between the reference and the reference build root and the reference nerve system, and then lots and lots of iterations. So as I mentioned, the processor was the same as the Raspberry Pi 02W. So knowing that it's the same Cortex A53 processor, the nerve system had gadget mode and was 64-bit, this definitely turned out to be a good reference platform. So build tooling. So I use the nerve system builder. This is really worthy of its own talk. I know that there's been some discussions of it, but basically the nerve system builder, the way it's sort of targeted is if you're running multiple nerve systems and wanting to update, build root versions and everything else, it's a good set of tooling to allow you to reconfigure and quickly rebuild. Also, instead of waiting for everything to go out to CI, you can do your builds locally and use that built image for testing your application. And the general steps are, you update the config EXS, basically pulling in your target system from GitHub or other locations. You do a clone to pull that in, mix ns.build to build it, and then in the output directory, your target actually works like build root. So if you're familiar with all the make commands for build root, it basically allows you to do all of those commands locally. The downside of the system is it is Linux only. I would probably recommend Debian or Ubuntu. I've gotten it to work for some systems on NixOS, but I'm not sure that it would work all the time. So the major things to change, it really, same thing you want to do anytime you want to do a custom system, is take the unique names. So anything where the RPI 02 was referenced, I updated that appropriately. Looked at what the build root packages were in the reference system, updated the kernel config, updated URL init, updated the partition tables, and then I knew I wanted to look at any boot files such as config.txt and commandline.txt that I knew were specific to the Raspberry Pi and remove those wherever they were referenced. So this is not a sophisticated script. It really is a quick and dirty compare script. Basically, I set up a script so that I could take build root config, sort it, remove all the comments, remove any, white space only lines, and just do a diff. And I'll sort of talk about how I did that for the different components. So nerf's def config is the main build root, the main part of the configuration for nerves and build root. So basically, I went through and looked at, the reference nerve system, my reference build root system, and just started looking at every line and trying to figure out what I needed to keep from the left and or what I needed to delete from the left and what I needed to add from the right. So things that you are going to be common is where do you get the kernel, the kernel. So I got the kernel from GitHub for this particular one. I know what the device tree setup should be. There's options for setting, custom device trees locally. Had to set things like the architecture, anything that needed to go on the boot partition, I needed to specifically reference. I included Cairo support for Scenic, updated the file system config, F2F tools, personal preference, and then really looked at any graphic options and made sure that instead of looking at the GL configuration for a Raspberry Pi device, I was updating it to the, I believe, Mesa drivers. So these are sort of the steps. It's a little messy, but basically I did the initial mix ns.build after I did some reconciliation, went into, the output directory, did make menu config. So there are things where you may need to go into the menu config and update, manually select some options. The other thing is you can get some dependencies. Some options have pre-dependencies, so you can always analyze why something you've added isn't getting enabled. I did make save def config. Basically, when I did the reconciliation, everything was sorted and very messy. So this is a way that it was able to, rewrite the build root config in a way that build root expects it and try to keep consistent. And then really just continue to validate the changes, continue to redo that diff and iterate through. Same thing with the Linux def config. Like I said, I could get the existing def config from a running kernel. I configured a null TTY personal preference, made sure to configure my file system. SquashFS is required for nerves. Enabled the appropriate I2C support, video, drivers, touchscreen, and watchdog. And these are similar steps, just going in and, validating the Linux menu config, updating it to normalize it, diff and iterate. So Erlinit is basically the init process used by nerves. So one of the things you want to do is, set your options for the TTY that's going to be specific to your device. Other option that I use in development but generally turn off in production is warn unused TTY. So think about the first time I'm booting this device, if I set the TTY incorrectly, then, on the screen it tells me, you're viewing this TTY, but, it's configured elsewhere. So just getting that name. Um, Mount options. So, like I said, partition tables vary between devices. And then another option we'll talk about more is locating the serial number. There's a program board ID that has been updated to support the Raspberry Pi, the BeagleBone, and get some values from U-Boot, maybe some other target platforms. But this being a bespoke device, that certainly wasn't an option. So my first attempt really was to take use FWUp, change the config, and simplify it to the minimum partition scheme that I thought I could boot the device. This is another area where I think it would be worthy of a talk. It's a very great program, but I know in the past it's taken me a little while to get my head wrapped around the way it works. Um, but generally, what I did is, define the partition tables, the boot, root, and app file system. I made sure that my device tree got copied to the boot partition, added bootargs.txt, which is the equivalent of command line.txt on the Raspberry Pi. So basically sets up all the kernel arguments for boot. Um, I removed the U-boot environment block, which in hindsight was a mistake, but it kept it simple. I removed any Raspberry Pi specific overlays and boot files. And so this is where I ended up. So this is, I went through the steps to bootstrap it, got it running, kept a very messy, Linux boot sequence, didn't turn anything off. You can probably not see it, but at the end, you can see toolshed and IEX. So at this point, I took a picture, sent it to Alex, and scheduled this talk. So if any of you are thinking about doing a talk for nerves in the future, there's nothing like scheduling the talk really will set a fire under you to get the project done. So now that I had a semi-working system, these are some of the issues I ran into and how I solved them. So one, no AB partition support. Certainly, I do not want to pull out this device, hold the first and fourth buttons, and get it into U-boot shell every time I want to update the application on the car thing. The data partition for some reason wasn't auto mounting. The serial number was defaulting to all zeros. Actually, sometimes it was nil. The nerves message of the day and the demessage log showed the hardware watchdog had issues. And then ultimately, this device isn't that useful if it doesn't have Ethernet and Wi-Fi support. So my fixes for the partition scheme. So the way that this works is I kept the AM logic partition scheme up until the logo partition. My intent was to still show a splash logo, but anything related to the legacy boot, I basically overrode those, reclaim that space, and put a standard, master boot record partition table, added a secondary U-boot environment partition. So the Spotify car thing does have a U-boot environment that it uses for a lot of logic and boot, so I didn't want to touch that, but I wanted the environment for setting nerves config values. So I set up basically the same partition, the AB partition scheme that a lot of the Raspberry Pi devices use, which is you have a boot A and a boot B, but basically only A or B partitions are active at the same time, and then a single application partition. And this is regardless of if you're doing a custom system for a port or you're really shipping an application, this is something that you're going to want to look at. My previous company, we we ended up having to repartition with devices in the field. So, take whatever percentage, whatever number you're comfortable with, but if you have the room, grow your, boot and root partitions appropriately. So after I did the partition scheme, got the AB partition support out of the box. Turns out the data partition not auto mounting was related to this environment variable that was set in U-boot, so that was fixed. And then the serial number not you know, defaulting to all zeros. I decided to do that in provisioning. Turns out the um, Spotify car thing or the underlying um, platform uses eFuses, and you can read that off of the running system. But I went through number of iterations and finally got a really long serial number and thought, well, if I've got two devices, why would I want to refer to them by some obscure serial number? So the watchdog is, I think, sort of interesting in that, so I'm using someone else's kernel config and device tree. Turns out that basically the watchdog, is hardware, has configuration for hardware and it just wasn't enabled. So I was able to create a device tree overlay, basically patching that. I could have done it as a patch and build root, but I decided to do this overlay. And then I went through a number of iterations where, in theory, U-boot can load your initial device tree and then an overlay and boot your kernel, and everything should just work. But it may have just been Spotify's, specific implementation of U-boot that did not work versus the reference. So I ended up um, combining the overlay with the existing device tree in the post build, script. So once I had the watchdog working, I started to go down into the support for host mode. So basically, a USB OTG adapter, think of it as a Y adapter where you bring in power on one side and then it splits out so that you can power the device and connect Ethernet or Wi-Fi or even a USB hub. So with this, I was able to find the correct, create an overlay that disabled the gadget mode and set up the USB port for host mode. Other issues, there was this weird purple and green sort of almost cyberpunk colors that started happening. It was actually started happening after I did the initial screenshot. Turns out from some discussions on the Note Superbird project, there's some conflict between the way U-boot sets up the display and the way the newer kernel does. The simple fix was just to remove the boot logo. IE console was portrait only. This ended up being a rabbit hole that went a lot longer than I thought. So basically, as I dug through the kernel config and looked at the source code, the particular video driver I'm using does not support rotation. This is one area where the Raspberry Pi does a great job on their VC4 video drivers to be able to support rotating panels and other things. So this is certainly something, you want to do early on in your process, is make sure if you're creating a device that you understand how your panel is going to be oriented and that you know that you have the right control over it. I can speak from my last job. We had a vendor that decided to change the orientation on the panel without updating the bomb part number. And because we were on Raspberry Pi, it was very easy to work around, but most platforms probably don't have that level of support. Um, and then where I left it is, if I want to go into USB gadget mode, I will have to update U-boot again and boot from there. But now that I have two devices, one working on Wi-Fi and one working on Ethernet, my intent is not to go back to gadget mode unless there's unless I have a catastrophic update. So this is sort of where the project is. When I was investigating the panel rotation, I knew that Wayland and the kiosk support would support rotations in the Weston INI file. So this was the first time that I had a working device that, was not just bugging the hell out of me being, 90 degrees flipped. But so I added all, took the reference Raspberry Pi kiosk, added Weston and Chromium, and the end result is, as you can see, the Phoenix Live dashboard. The touchscreen works. It seems to be pretty responsive. I haven't dug in much from there. Scenic. So basically, the project that I started was the simplest scenic project ever, which is just to display a clock. My intent is to build this out more. I mean, as I look at this device, you've got 4 buttons off the top. It should be really easy to switch scenic scenes on GPIO. Touchscreen is working. I have not figured out, the if I can do volume control or other things, but that's definitely to be done. So bootstrapping, this is a little bit where, it is scary, but I definitely want to encourage people, if they can get their hands on a car thing, to try this, because ultimately, I don't know how many units that Spotify sold, but this is quickly becoming e-waste. And it this is definitely the easiest platform to use, so far I've seen out of the hacking community, the fact that Wi-Fi and Ethernet are working. So the basic idea is to boot using an NRD. There's a lot of steps to go through, and should do a backup of everything ahead of time. But step 2 is to back up the bootloader. There's steps for restoring the decrypted device tree overlay. So this is the device tree overlay with the older kernel. Update the partition table. So like I said, I basically pruned everything after the logo partition. Then SCP the Superbird clock app up to the device. Apply that clock app using FWF, which will format the partition and apply the firmware. And this is where between steps 2 and 6, if you don't do step 7, that's where I believe you would break the device. I'm not absolutely sure. If anyone wants to sacrifice a car thing for that effort, I welcome it, but I have not tried it. Then step 8 is to reboot into burn mode. And then now that you have a working file system on the car thing, is update U-boot environment to either boot from gadget or host mode. And that's sort of all I have. I should say if you want to reach me, probably the easiest way is on Elixir Lang Slack. I think I posted 2 times on Blue Sky in the year, so I'm not a huge social network user, but you can reach me there as well.
Awesome. Thank you, Eric. Everybody, feel free to unmute yourself now if you'd like to ask Eric a question. I guess I'll warm things up there and say, Eric, about how long do you think it took you to get the device from this point for porting all this over?
I should have kept better time, but I think because I went down a bunch of rabbit holes, including especially the rotation, it might have been 4 days, you know. And this was I had done build root customizations, but I had never done this level before.
Cool.
Yeah, and I should also give a shout out the grid point um, GitHub Actions for NERS build support was definitely very useful because one of the things that I've quickly found out is Circle CI doesn't like when you set up a new project and kick off a build that takes over an hour and a half. They tend to immediately put you in the you're committing fraud zone. So I would probably recommend someone give a talk on that and maybe moving the community over to that.
That's the great point. I should probably shout that out. So John Ringel from Gridpoint has ported over the original Nerve CI tooling, which is still out there. There's a Circle CI orb to help compile Nerve systems. John ported that over to GitHub Actions. The limitation that Eric just mentioned with Circle CI is on their free tier, they'll limit your compile times to an hour. So your builds will get canceled if they start running over that hour. I can tell you we've upgraded commercially. Unfortunately, for our open source stuff, they've got a generous open source limit, but when you're over that hour, we just started paying for it, honestly. And if you're on the paid plan, you don't have that 1 hour limit. So if you're working on a commercial project and you're on Circle CI, you're using the Nerves orb for it. If you run into that limitation and you're on the free plan, I'd say just pay for it and it'll at least get you unblocked, and then you work on probably porting over to GitHub Actions.
I'm actually diving into some of the AM logic stuff in U-Boot. I did drop the comment in, or some info that I found, quick Googling on the chat here. I found that it's based off the AM Logic S905D2 processor, and there is an Odroid C2 board. I actually might have that one. I have to see in my bins and see if I actually do have it. I know I have 1 or 2 Odroid boards laying around. I just don't know if it's the C2 or another model. But if since the Odroid C2 board has the same processor, it might be a good thing to get nerves on that device. That way, you're working through U-Boot, working through Linux on the same processor. It's just a little bit more friendly and unbreakable. So
Right.
when you get your U-Boot working on the Odroid device, it should just work on the car things. Granted, you will have to bring over that device tree source or device tree blob that is currently working on the car thing, so that U-Boot can actually initialize all the devices properly, and also Linux can see all those devices properly.
Yeah, that's a good point. I did specifically decide not to invest in a dev kit, which, made it more interesting.
Yeah, living on the edge there, very dangerously.
Yeah. Oh, and I guess I do have a couple devices here. Not great lighting for it, but this is the basic display. Yeah. Pictures are definitely better than that, but And then the other is there is my clock sitting on my desk. So,
That's pretty cool. So did you get the inputs on the front working yet? Or did you see how those come in through the device tree? Like, can you pick them up as input events, or is it something else?
in theory, the GPIO works. To be honest, I don't think I tested it. I did see that they showed up in the dev file system.
Okay, cool.
That seems like a ton of stuff that you got through in 4 days. It sounds, I think it would take me 4 years or maybe decades.
And I can say one thing I did not say in the presentation is I didn't optimize. So when I say I was literally looking at the left and the right and trying to figure out what to keep and what to prune, anything that I recognized that was specific to the Raspberry Pi, I pruned, but ultimately I didn't trim this down to be something that I would want for a production system.
So with the state that it's in, should we all go out and buy Spotify things? And
To be honest, I would love there to be an army of people trying to just reclaim them from the dump. I would love for, and I didn't sort of talk about, I, I didn't get creative, but ultimately, as I look at this device, I'm like, it would be a decent screen for a 3D printer. It would, there are definitely some uses for this, but right now, the marketplace, people are selling them probably close to the original price, and they were never worth that. But at some point, people are going to have the choice of put it in the dump or put it in e-waste or give it away, hopefully.
The 3D printer screen is an interesting idea. Have you torn one of those apart or done a tear down to see what's inside and how easy it would be to put your own custom enclosure around it or hook up your own custom I/O to it?
The original hack had where they broke open the case and it did not seem clean at all. So the way that it is configured, I would not, I would basically rely on, the single USB port. And like I said, I did connect it to a hub, with a hub where I had on-off buttons so I could switch between Ethernet and Wi-Fi. So the hub does work as well.
That's good to know. Was that an active hub, or does it have enough juice to power some passive USB devices off of it?
I used an active hub, but it's but with the Y connector, it's basically Actually, I should show that just so people know what that looks like. So this is basically what the Y connector looks like. So a single USB power in here, and then your USB-C and then USB-A. So and I had to specifically add, the Ethernet drivers for the pile of stuff I had around the house, and the Wi-Fi drivers for the USB-A Wi-Fi chip I happen to have, but otherwise it was pretty straightforward.
Cool. So you've got, off of that USB cable, you've got a USB-A to Wi-Fi dongle that you plug in there for Wi-Fi, and then it's the same type of thing for Ethernet to get out to Cat5. Cool.
Yeah.
Well, not a question, but Eric, that's really cool. I really benefited from seeing the process you went through. Hopefully I can use this for my own my own nefarious needs too. So thanks for presenting.
Oh, you're welcome.
Do you have any plans for the product for yourself?
I tell you, I probably will. I think the next thing I need to do is, I have this, somehow I actually like the clock, but I need to create a clock in my son's room where it will be dark at night. Because, I that was the first Nerves project I actually did would say nerves in production, and something that I actually used was a sun moon clock for when he was a toddler. So it was like at 7 a.m. Or 6 a.m. it would be blue, like, yeah, I know you're awake, but stay in bed. And then at 7 it would turn yellow, just to be like, okay, you can come out of your room now. So it's definitely useful for kids of any age.
Nice. So I actually have a phone mounted to a wall that I use as a security camera, or a screen for my alarm system. Something like that would be nicer, because I have to then have the whole phone's operating system, and it's ADT, so like their whole archaic, you know, JSP based system. So it would be nice to have something, you know.
Yeah, and like I said, the Debian kiosk, I look like someone set up Home Assistant, which I don't know how easy that would do with nerves, but and the fact that you have a Chromium console, really, the sky's the limit if you want to create it with, Phoenix and Live View.
I do have a question, and I was kind of reading the text, and I may have mentioned you if you said this about how long does it take to go from power on to your Scenic dashboard on this build?
That's a good question. I can try it, but generally, I think it's somewhere around 30 seconds or so. But let's plug it in now and let's see. Yeah, the boot logo is a shame, because that definitely does not give me a lot of feedback.
Yeah, the trick that we would do in some older products is to have the most bare minimum set of basically
Yeah.
an animation you could step through regardless of what was happening in the background. I don't know if that's possible without some hacked up Linux and
Yeah.
bootloader or U-boot stuff.
I think what Avelina mentioned is getting the reference platform and actually configuring U-boot would be the right thing to do. But it's looked like it took somewhere around 45 seconds or a minute,
And more random stuff as I'm just coming up with nerd questions. So I like your slide layout. Is that custom, Markdown driven? What do you use for your
Actually,
slides?
you use Google Slides, but
Google
for some
Slides.
reason I decided to go down the Dolly somehow I came up with the rabbit hole first, and then I made all the layout go with custom Alice in Wonderland.
It's cool.
And I will, at some point probably do a blog article. So whenever this presentation is uploaded, I'll try to include some links to resources. But I'm hoping Avelino or someone else has a more refined process. I did call it a quick and dirty compare script for a reason.
Yeah, Avelina, what's the gist of your process?
It depends, but quick and dirty works to get something, getting the proof of concept going, and then refining afterwards is usually what I end up doing. So I like quick and dirty.
I'll have to twist your arm into the full nerves presentation at some point, but Eric mentioned the nerve system tooling to be able to compile multiple nerve systems to set the environment of the system you just compiled so your application can pick it up and so on. What's your rough method around that for tooling around how you iterate?
Well, if I'm working on a product, I don't necessarily need to compile multiple systems at a time or multiple different systems at a time. It's just the one that I'm working on, and I mostly live in the shell inside of the actual build root directory. So inside of .nerves, artifacts, the name of your system, portable, and then the version of the current version of your system. So inside of that directory, you have the ability to make clean, build particular packages. So if you're working on adding additional functionality like OpenSSL or some other third-party library that you need, for example, Wayland or something that uses Wayland like WL Roots or Hyperland or one of those other Wayland-based window managers, you'll be probably living in that shell for a very long time, getting your packages to actually build. They're cleaning, rebuilding, and using menu config also in make menu config in or sorry make menu config for build root and make Linux menu config uboot menu config for menu config for Linux and uboot respectively, to add additional configurations that you might need for the kernel or the bootloader. And oftentimes that might or might not require rebuilding the kernel or bootloader from scratch. So again, make dirt clean and then make all to make sure everything gets built. That's usually where I end up living for quite a bit until I get to packaging everything up into some sort of image that I am then ready to try to flash onto the actual device. And at that point, you're in rootfs land, and also using swap and additional swap and friends tooling to package the distro up.
Yeah, I should say that it was actually a cheat. I used the same method you used, which was to find the nerves artifact and iterate there. But once I had everything working, I'm like, well, the nerve system builder, actually works better for this. But I think that is another thing is just, I think basic customizations of the nerve systems, I think there's still some trepidation in the community, but I keep trying to tell everyone it's just build root. So once you know how to clean and reconfigure individual packages in build root, it's, you can iterate pretty quickly.
Oh, absolutely. And it's just build root. Like that one liner I can't stress that enough. It's something that is greatly overlooked, but it's 100% the fact to know, because when you demystify what nerves is, um, nerves in its entirety is probably like 5 different packages that are custom that Frank and the core team have developed over the course of so many years. But it's those 5 packages that allow you to boot into the beam as PID 0. And everything else is built root and the packages that are required to boot the rest of your system. So Linux, your bootloader, so on and so forth. And built root is the distribution tool to build everything, to glue everything together and package it up. So yeah, it's great that you're starting to see that. But yeah, it's all it is. It's all build root.
Anyone else have thoughts? All right. Well, thank you very much, Eric.